Hello, this is Mrs. Pullen for the Unit 9 review sheet for Algebra 2. And in this video, I'm going to go over how to solve exponential equations using the same base method or the common base method. We're going to start with problem number 20, and this was actually from an Algebra 2 Regents a number of years ago. And the first thing I look to do is see if there's some sort of base I can make or some sort of way I can make both the base of 81 and the base of 27 the same. And so I see 27 and it comes to mind that 27 is the same thing as 3 cubed. So I'm going to rewrite 27 as 3 cubed, and that's going to be raised to the power of 5x over 3. And on the left-hand side, I know, and if you were unsure, you could test it out in the calculator, that 81 is the same as 3 to the 4th. And you're raising that to x cubed plus 2x squared. I then am going to apply the power rule and distribute that 4 to both of the terms in the exponent to get 3 to the 4x cubed plus 8x squared. And on the right-hand side, I'm going to multiply 3 times 5x over 3. Well, that's the same as 15x over 3, which is the same as 3 to the 5x. My bases are now the same, so I can ignore them, and I just set the exponents equal to each other. This is some sort of polynomial, so I'm going to put it into standard form by subtracting 5x from both sides of the equation. And next, we're going to factor. When you factor, you always start with the GCF, and the GCF is, in this case, x. Don't lose it. So you get x times 4x squared plus 8x minus 5. And now we're going to factor. Now, you could use the quadratic formula, but it's actually faster to factor. And so you can use whatever method you like. You can use split the middle, I know some people like. You can use trial and error. Again, you could use the quadratic formula. It's just going to take a little longer. So I am going to factor using trial and error. So I'm going to make this 2x and this 2x. And I'm going to try 5 and 1. And I'm going to try plus 2x plus 5 and 2x minus 1. And I double check to make sure that that works. So my inner term multiplies out to negative 1 times 2x or negative 2x. My outer term multiplies to 2x times 5 or 10x. And when I add down, I get positive 8x, which matches the middle term. So I know I factored it properly. I'm just going to rewrite it in the numerator because it's a little messy right now, and I want people to be able to follow the work that I've done. It's really important, actually, that, it's not just my answer key, but when you're writing a problem, it should be very clear to the reader, the one who's scoring your exam, how you arrived at your answer. Really important. In any case, we're going to set each linear factor equal to 0. And we're going to solve. So one solution is x equals 0. I'm going to add 1 to both sides to get 2x is equal to 1. X is equal to 1/2. I'm going to subtract 5 from both sides. I get 2x is equal to negative 5. X is equal to negative 5 over 2. So I have 3 solutions, and you really need to check all 3. And there are multiple ways of checking, but I find the easiest way is to use the graphing calculator. And so we're going to store, let's start with negative 1/2. So you go into the calculator and you go negative 5 divided by 2, control store x. And now we're going to type the right-hand side, so 81x cubed plus 2x squared. So 81 caret, um, oh my gosh, I forgot, x cubed plus 2x squared. And that gives me a crazy looking number. And now I'm going to do 27 raised to the 5x over 3. So 27 caret, control division, 5x over 3. And you get that same crazy looking number. We now want to try the other values. So one was 1/2 and one is 0. So 1 divided by 2 controls store x. And what I like about using the store feature is I can be a little lazy and just go to the expression that I already typed in and hit enter. And then I can go to the second expression and hit enter. And I see that matches. And now we're going to hit store, zero control, zero control store. I'm making a mess of it, sorry. Control store X. So you get that arrow and store it in X. And again, I'm going to copy and paste. And you see that all three solutions work, so it checked. Let's go to problem number 18. Now, when we look at 18, we see this huge base, and that can be a little intimidating. And I see the base of 512. And so, again, you want to have the same base, and you could work with small numbers, but I'm going to guess. Let's see what happens. This is where the calculator is really useful. What happens when I type in different values? So I'm going to just open up a new calculator page. And if I go 512 caret 2, so I square it, I get 262,144. It matched. So it turns out that I lucked out that 262,142 is the same thing as 512 squared. And now I'm going to raise that to the x minus 2. For the right-hand side, I notice that 512 is under 1. Remember, there's an invisible 1 here. And I really want to have a plain base of 512. So all I need to do is now negate my exponent. And I'm going to raise it now to negative 3x plus 3. I distribute the 2, and I get 512, 2x minus 4 is equal to 512. Carefully distribute that negative, 3x minus 3. My bases are now the same. And so now I get 2x minus 4 is equal to 3x minus 3, and I solve. I'm going to subtract 2x from both sides. I get x minus 3 is equal to negative 4. I'm now going to add 3 to both sides. And so now negative 1 is equal to x. And so my final answer is simply negative 1.